When the German army retreated through the shattered landscapes of France in 1944, its soldiers left behind a trail of wreckage. Bridges lay twisted in rivers, craters pocked every mile of road, and convoys struggled to move through the mud and rubble. The Luftwaffe had long believed that by destroying infrastructure, they could halt the Allied advance. Yet within days, sometimes within hours, the same roads that had been turned into smoking ruins were once again alive with the movement of American trucks and tanks. Dust rose not from chaos but from construction, from convoys of bulldozers, graders, and mobile asphalt mixers that worked through the night under the dull glow of lanterns and headlights. To the Germans watching from captivity, or from the hills beyond the front lines, it seemed as if an invisible army followed the Americans wherever they went, an army that could rebuild faster than destruction could spread. They had been trained to think of logistics as a rigid chain, something that broke under pressure. What they saw instead was a living organism, an engineering machine that adapted, reassembled, and advanced no matter what the battlefield demanded. In the ruins of Normandy, the Americans built temporary bridges across rivers that had swallowed entire armored divisions. In the forests of the Ardennes, where snow and artillery fire turned the ground into a mire, engineers laid down steel mats and wooden planks to keep supply trucks moving. Along the coast, roads bombed by the Luftwaffe were patched with crushed stone, oiled, and resurfaced in less than 48 hours. There was no pause, no hesitation, only the rhythm of machines and men who treated the war itself as a construction project to be managed and completed. German prisoners later described their disbelief at how fast the Americans restored movement. They had grown up with the image of the Blitzkrieg, lightning war, a strategy where speed came from destruction. Yet here was a different kind of speed, born not from breaking things but from repairing them. In captured diaries, some officers wrote that the Americans built as if they were racing time itself. Others noted that entire units of engineers seemed to move like industrial workshops, setting up roads and bridges with the precision of factory assembly lines. The paradox was striking: the faster the front collapsed, the faster the roads reappeared. To many Germans, it felt as if the Americans carried civilization in their trucks, the power not just to advance, but to rebuild the very ground they fought on. Each repaired bridge and resurfaced highway became a quiet declaration of intent that the war, however destructive, could not erase the infrastructure of progress. Even under the smoke of battle, the United States Army Corps of Engineers embodied a philosophy that stunned its enemies. That movement itself was victory, and that no amount of bombing could stop a nation that had learned to build faster than it could be destroyed. This sight, convoys of engineers working in silence while artillery thundered in the distance, marked a turning point in how the Germans understood their opponent. They had met armies stronger, faster, more disciplined. But they had never faced one that turned logistics into a weapon and engineering into a form of warfare. The roads of Europe, once symbols of retreat and ruin, became monuments to an idea that power was not just about the ability to destroy, but about the will to rebuild. The German army entered the Second World War with a reputation for precision and order. Its logistics system was built like a clockwork mechanism, designed to function flawlessly as long as every cog turned exactly as planned. Roads, railways, depots, and fuel lines were mapped months in advance. Supply convoys moved according to fixed schedules, and engineers operated under the assumption that infrastructure, once established, would remain intact. This philosophy had served Germany well during the early Blitzkrieg campaigns, where rapid victories and short distances kept supply routes stable. But as the war stretched across continents and destruction became constant, the very rigidity of this system became its weakness. German logistics depended heavily on railways, a network that could deliver supplies with unmatched efficiency but was vulnerable to the smallest disruption. When bridges were destroyed or tracks bombed, entire divisions could be immobilized. Repair crews worked methodically, often waiting for precise orders before acting. The command hierarchy, built on strict discipline, discouraged improvisation. A single broken link could paralyze an entire army. By contrast, the Americans approached logistics not as a fixed system, but as a living organism that could reconfigure itself in real time. The German engineers were trained to preserve structure. The American engineers were trained to create it anew. Where the Wehrmacht saw destruction as an obstacle to be cleared before movement could resume, the United States Army Corps of Engineers saw it as the starting point of their work. German doctrine had no equivalent to the American concept of combat engineering, the idea that construction and battle could occur simultaneously. In German planning, roads were built before the army advanced. In American practice, they were built as the army advanced. By 1944, this difference had become decisive. The retreat from Normandy exposed how vulnerable the German logistical system was. Bombed railways and cratered roads created bottlenecks that the Wehrmacht could not overcome. Thousands of fuel trucks and ammunition wagons were abandoned because there was simply no way to move them. The army that had once conquered Europe by speed was now trapped by its own infrastructure. In reports to the Oberkommando der Wehrmacht, officers described complete disorganization of transport and impossibility of coordinated repair. The system designed for control could not survive chaos. Meanwhile, the Americans thrived in chaos. Their supply chains were flexible, redundant, and supported by mobile workshops, pontoon bridges, and prefabricated road sections. German officers, trained to think in terms of perfection and order, struggled to comprehend an enemy that valued adaptability over precision. In the Wehrmacht, every delay was a failure. In the U.S. Army, every delay was an instruction for the next innovation. This cultural difference extended beyond engineering. It reflected two worldviews, one that saw war as an operation of control, and another that saw it as a process of constant adaptation. The Germans tried to maintain the purity of their system, but the battlefield of 1944 no longer rewarded order, it rewarded improvisation. When bombs tore through French roads, American engineers were already laying new ones beside them. When bridges collapsed, floating pontoons appeared the same day. The German high command could not understand how their enemy moved so quickly, because their own doctrine did not allow for movement within destruction. In essence, the problem was philosophical as much as logistical. The German system depended on the assumption that war could be managed. The American system accepted that war could only be endured through motion. Where the Germans waited for stability to act, the Americans created stability by acting. That difference, between preserving structure and generating it, marked the turning point of the war's infrastructure battle. It was no longer a question of who could destroy faster, but who could rebuild faster. And in that contest, the Germans had already lost before they realized it. During the Second World War, the United States Army Corps of Engineers became one of the most vital yet least celebrated forces on the front lines. Its mission was not to capture ground, but to make ground usable, to ensure that the relentless machinery of war could move forward regardless of destruction. From the beaches of Normandy to the heart of Germany, the engineers turned chaos into order with a precision that mirrored American industry itself. Their legacy was not measured in battles won, but in miles of roads rebuilt, bridges raised, and rivers crossed. The foundations for this achievement had been laid long before the first American soldier landed in Europe. In the interwar years, the U.S. Army recognized that any future conflict would demand unprecedented mobility. The stagnant trench warfare of World War I had demonstrated the fatal cost of immobility. Thus, between 1919 and 1939, American military planners began developing doctrines that fused engineering with logistics. The idea was simple yet revolutionary: an army that could not move could not win. To solve this, the United States invested in training engineers not just as builders but as combatants, soldiers capable of constructing under fire. By the time the United States entered the war in 1941, it had already transformed its industrial base into the greatest manufacturing engine the world had ever seen. The same factories that produced cars and farm equipment began turning out bulldozers, graders, cranes, and portable asphalt plants. Civilian expertise merged with military discipline. The result was the creation of highly specialized engineer units, such as the 354th Engineer General Service Regiment, the 1104th Engineer Combat Group, and countless battalions tasked with bridging, road repair, and demolition. These units operated under the motto, Essayons, "Let us try," a reflection of their adaptability and determination. Their methods were based on the principles of standardization and modular design. The engineers worked with prefabricated components that could be transported and assembled in the field. Bailey bridges, developed in Britain but perfected by American units, became symbols of this approach, portable steel structures that could carry tanks and trucks across rivers within hours of a collapse. The same philosophy extended to roads. Instead of rebuilding them stone by stone, engineers used compacted gravel, bituminous surfacing, and steel matting to create durable, temporary highways. Every operation was treated as an industrial process: measure, prepare, execute, move on. After the Normandy landings in June 1944, the scale of their work became immense. The invasion beaches themselves were an engineering marvel, layered with floating docks, artificial harbors known as mulberries, and a web of roads built from steel Marston mats. Once the front lines broke through the hedgerows of Normandy, the engineers followed with an almost mechanical rhythm, widening country roads, paving over bomb craters, and laying pontoon bridges over every river obstacle from the Seine to the Rhine. Reports from the European Theatre of Operations recorded that between 1944 and 1945, U.S. engineers repaired or constructed more than 24,000 kilometers of roads and erected over 1,200 bridges. The work rarely stopped. Rain, snow, or artillery fire only slowed it briefly. In Belgium, during the bitter winter of 1944, engineers labored through freezing nights to repair the road networks that fed Patton's Third Army during the Battle of the Bulge. They worked under constant threat of air raids and sabotage but maintained supply lines that allowed fuel, food, and ammunition to reach the front. Every hour a road was passable meant another hour of momentum, and momentum was what defined the American style of warfare. This industrial mindset reflected the broader philosophy of the United States during the war. America fought with factories as much as with rifles. Its engineers were extensions of Detroit's assembly lines, Ford's production models, and the logistical thinking of the War Department. Every bridge or road was not an isolated act of repair but part of a continuous system that spanned oceans. Supplies flowed from ports to depots to frontline units through an infrastructure designed for constant motion. The goal was not to preserve the old roads of Europe, but to build a new network capable of sustaining the pace of modern mechanized war. By the war's end, the U.S. Army Corps of Engineers had proven that mobility itself was a weapon. Their work redefined how an army could operate, not as a force that waited for stability, but as one that created it. From the ruins of France to the plains of Germany, they turned destruction into passage, teaching the world that engineering was not merely a technical skill but a philosophy of endurance, precision, and progress. The turning point in the evolution of American wartime engineering came with the birth of mobile engineering, a concept that redefined how infrastructure was built and maintained in combat. Before this innovation, armies throughout history had viewed engineering as a secondary, reactive function. Bridges were rebuilt only after they were destroyed, and roads were repaired only once the battle had moved elsewhere. The United States Army Corps of Engineers overturned that logic. It transformed construction from a logistical necessity into a frontline operation. Engineering ceased to be static support. It became a living, mobile force that advanced with the troops. This transformation began in North Africa in 1942, where early campaigns revealed the limits of conventional engineering. The terrain, vast and unpredictable, forced American commanders to rethink their dependence on fixed supply bases. Roads were constantly shifting, sandstorms erased tracks overnight, and moving construction materials across hundreds of miles was nearly impossible. The solution was radical: bring the factory to the front. Instead of relying on rear depots, the engineers began transporting prefabricated bridge sections, portable workshops, and compact road-building machinery in convoys that moved alongside combat units. This philosophy marked the birth of mobile engineering, the idea that infrastructure could travel with the army rather than lag behind it. By the time of the Normandy invasion in 1944, the system had reached industrial maturity. Specialized vehicles carried everything from portable cranes and bulldozers to mobile asphalt mixers and folding pontoons. Each engineering battalion functioned like a moving construction company, capable of building airstrips, roads, and bridges within hours. The Bailey Bridge became the emblem of this philosophy. Designed in Britain and refined by American engineers, it was made of standardized steel panels that could be assembled by hand without heavy machinery. A 60-foot bridge could be constructed in less than 6 hours, and entire spans across major rivers like the Seine or the Rhine could be completed in a single day. Equally transformative were the developments in road-building materials. The engineers adopted Marston mats, perforated steel planks originally created for temporary airfields, to stabilize muddy terrain and create instant highways for tanks and trucks. In the wet fields of Normandy and the forests of Belgium, these mats turned chaos into mobility. Later, the U.S. Army introduced portable asphalt plants mounted on trucks, allowing teams to mix and pour road surfaces on the move. What had once required a stationary construction site could now be accomplished under fire, at the edge of battle. Behind these innovations was a culture of experimentation driven by necessity. Military engineers worked closely with scientists and industrial designers in the United States to translate civilian technology into field solutions. The engineer board at Fort Belvoir in Virginia tested everything from new bridge designs to mobile water purification units, ensuring that by the time a piece of equipment reached Europe, it had already been refined for speed and reliability. The collaboration between the military and private industry, companies like Caterpillar, U.S. Steel, and Chrysler, gave the American engineers a level of technical flexibility no other army possessed. In practice, mobile engineering was more than just a technical advancement. It was a strategic catalyst. It allowed the U.S. Army to maintain the momentum that defined its operations in France and Germany. Roads destroyed by German air raids were rebuilt before dawn. Bridges blown apart by retreating forces were replaced before the enemy could regroup. Every obstacle became an opportunity to demonstrate how movement itself could overpower destruction. This doctrine of constant reconstruction turned engineering into an act of warfare. It blurred the line between battle and logistics, between front and rear. The same trucks that carried soldiers into combat carried the means to rebuild what combat destroyed. In this new form of war, the engineers were not simply repairing the path forward, they were creating it in real time. The catalyst of mobile engineering did more than solve logistical problems. It redefined the tempo of modern warfare. It proved that adaptability could defeat precision, and that mobility was the ultimate weapon of an industrial army. From the beaches of Normandy to the banks of the Rhine, American engineers showed that progress could move on wheels, cross rivers on steel, and build faster than war could tear down. The daily work of the American engineer battalions during World War II resembled an industrial symphony performed under fire. Their operations were a blend of discipline, improvisation, and sheer endurance. Every movement was measured, every task divided into teams that functioned like the gears of a vast machine. While infantrymen fought for ground and artillery pounded distant hills, engineers worked just behind the front lines, often within range of enemy shells, to ensure that the army never stopped moving. Their unofficial motto, "Keep them rolling," was more than a slogan, it was the lifeline of the Allied advance. Each engineer unit operated as a mobile construction company and a combat force simultaneously. The day often began before dawn, when reconnaissance teams scouted damaged roads, collapsed bridges, or bombed culverts. Using aerial photographs and field reports, officers drafted rapid repair plans, sketching them on maps spread across the hoods of jeeps. Bulldozers, graders, and cranes were then brought forward in convoys that followed the same routes as the infantry. The engineers' movements were timed with precision, arriving within hours of the first breakthrough, often while artillery fire still echoed in the distance. The process of road reconstruction began with clearance. Mines had to be removed, wrecked vehicles dragged aside, and the ground leveled under threat of sniper or mortar fire. Bulldozers and scrapers pushed through the debris, cutting new paths when the old ones were beyond repair. Gravel was poured, compacted, and graded by heavy rollers that worked in shifts around the clock. In wet terrain, engineers laid down steel Marston mats to create instant traction for tanks and trucks. Within a single day, a landscape that had been impassable could become a functioning highway capable of supporting thousands of vehicles. Bridge construction followed a similar rhythm of speed and precision. When retreating German forces destroyed crossings, engineer companies immediately deployed Bailey Bridge sections carried on trucks and trailers. Each bridge crew was divided into specialized teams. One assembled the steel panels, another positioned pontoons or supports, and a third managed anchoring and load testing. They could build in daylight or darkness, using searchlights or vehicle lamps covered with tarps to hide from enemy aircraft. In favorable conditions, a bridge spanning over 100 feet could be completed in less than 8 hours. Once traffic began to flow, the engineers moved to the next site, leaving maintenance teams behind. Coordination was essential. Engineers worked closely with quartermasters, signal units, and combat commanders to synchronize their efforts. A single road repair could affect the movement of entire divisions. Command posts maintained continuous radio contact with engineer units, adjusting priorities as battles shifted. If a supply route came under fire, alternate paths were marked, cleared, and opened within hours. The system relied on constant motion, one team building while another planned, a third already en route to the next objective. There was no idle moment, no fixed position. The process itself was a form of warfare. To sustain such pace, the U.S. Army standardized its equipment and methods. Tools, vehicles, and construction materials were interchangeable across units, allowing any engineer battalion to pick up where another left off. Mobile depots stocked prefabricated bridge components, fuel, and spare parts, delivered in a continuous stream from the rear echelons. Training in the United States had prepared these men for exactly this kind of efficiency. At Fort Belvoir and Camp Claiborne, thousands of engineers had practiced building roads, pontoon bridges, and airstrips under simulated combat conditions, learning to work under pressure without hesitation. The conditions they faced in Europe were brutal. Mud swallowed machinery, cold froze asphalt, and shells cratered freshly repaired roads. Yet the engineers adapted relentlessly. They learned to mix gravel and tar in rainstorms, to build timber supports from wrecked farmhouses, and to repair vehicles with whatever materials were at hand. Their strength lay not just in their tools, but in their resourcefulness. Every obstacle became a problem to solve, and every solution fed into a larger rhythm of continuous movement. The sound of their work became as familiar as the sounds of war itself, the roar of bulldozers, the clang of steel girders, the hiss of steamrollers smoothing a new roadbed. To soldiers who passed through their constructions, the engineers seemed tireless, almost mechanical. But behind that efficiency was exhaustion, danger, and an unspoken understanding that time was the real enemy. Every minute a supply truck waited meant another frontline soldier without ammunition or fuel. In the end, the process was not just about rebuilding roads or bridges. It was about maintaining the heartbeat of the entire Allied campaign. The engineers fought not with rifles, but with shovels, wrenches, and blueprints. Their battlefield was measured in miles of progress, and their victories were silent. A truck that arrived on time, a bridge that held under weight, a column that kept rolling forward. Through method, courage, and relentless motion, they turned the act of construction into an instrument of war. During the winter of 1944, as the Battle of the Bulge raged across the dense forests of the Ardennes, German prisoners captured in the chaos of retreat witnessed something they could scarcely believe. The American engineers, who had followed the advancing forces into this frozen and devastated landscape, began rebuilding the destroyed roads almost as soon as the fighting moved past them. What had been impassable terrain only hours before, clogged with felled trees, shattered bridges, and shell craters filled with ice, was transformed overnight into functioning arteries of movement. At dawn, convoys of American trucks rolled across newly laid gravel and steel mats, carrying fuel, ammunition, and food to the front lines. To the exhausted German soldiers, this seemed less like war and more like a feat of industrial magic. The engineers worked in near silence, their efficiency a stark contrast to the confusion of battle. Bulldozers pushed aside wreckage and debris, graders leveled the mud, and mobile asphalt mixers poured black ribbons of road that steamed in the morning frost. The Germans, who had been trained to think of road building as a rear-area operation requiring weeks of preparation and materials, were astonished to see it done in hours. One captured German engineer, interrogated weeks later, remarked that the Americans moved like a factory on wheels, capable of reproducing entire sections of infrastructure wherever they stopped. For him and many others, it was the first time they had seen construction carried out with the same speed and organization that the Wehrmacht once associated only with destruction. In Normandy months earlier, the same phenomenon had played out under different conditions. There, the enemy had not been snow and ice, but mud and rain. The endless downpours turned the hedgerows and fields into quagmires that swallowed tanks and trucks alike. Yet even in that terrain, the engineers had refused to halt. Using Marston mats, perforated steel sheets originally designed for the construction of temporary airfields, they laid down thousands of square meters of roadway, creating instant surfaces that allowed supply vehicles to move despite the mud. The mats were joined together with bolts and clamps, forming a metallic carpet that could be rolled out, extended, or dismantled at will. What had been a farmer's field in the morning could become a motor pool by afternoon. German officers who inspected these makeshift routes after capture could hardly comprehend how they had been built so fast. They had assumed that rain and bombardment would slow the American advance, but the engineers simply adapted their methods. When bridges were blown, they used pontoons. When the ground was too soft for vehicles, they reinforced it with steel and gravel. They brought their own quarries, workshops, and even small asphalt plants, all mounted on trucks and trailers that moved with the columns. It was a system designed not to wait for ideal conditions, but to create them. In the Ardennes, this adaptability reached its peak. The Germans had launched their counteroffensive in part because they believed the weather and terrain would cripple Allied logistics. But instead of halting the advance, the snow and mud merely provided a new challenge for the engineers. They worked under constant threat of shellfire, sometimes in darkness, marking their roads with white tape and lanterns so convoys could find their way through the blizzards. When frozen rivers blocked the route, they built wooden trestles and pontoon crossings in temperatures that froze tools to their hands. The roads they built were not beautiful or permanent, but they endured long enough to keep the army alive. For many of the German prisoners who later reflected on these scenes, it became clear that they were witnessing a new kind of warfare, one defined not only by firepower but by mobility. The Americans did not merely conquer territory, they reorganized it. They treated the landscape itself as an extension of their logistics, reshaping it with machines and manpower at a pace that no army in Europe had ever matched. The Germans, who had once prided themselves on precision and order, now found themselves overtaken by an enemy that built order out of chaos. The field experience of those winter months left an enduring impression on both sides. For the Americans, it proved that their doctrine of continuous movement could withstand even the harshest conditions. For the Germans, it was an unsettling revelation that the true strength of their opponent lay not in numbers or weapons, but in the ability to rebuild faster than destruction could take effect. In the frozen roads of the Ardennes and the muddy fields of Normandy, they saw a glimpse of the future of war, one where the front was not a line on a map, but a moving network of roads, bridges, and machines that refused to stop. The influence of the American Engineering Corps during World War II extended far beyond the immediate victories they enabled on the battlefield. Their methods reshaped not only the outcome of the war in Europe but also the very definition of what constituted modern warfare. Before 1944, most armies viewed engineering as a secondary function, a support service that followed combat operations. The United States Army, however, had turned it into an offensive instrument, a force that could alter the physical landscape faster than the enemy could adapt. The rebuilt roads, bridges, and supply lines became silent weapons that decided campaigns long before the shooting stopped. In the European theater, the impact of engineering efficiency was felt most acutely after the Normandy landings. The ability to rebuild infrastructure in record time allowed the Allied armies to sustain the speed of their advance across France and into Germany. German defenses that relied on destroying bridges or flooding valleys quickly became ineffective. For every obstacle the Wehrmacht created, the American engineers produced an answer within hours. Roads demolished by retreating forces were reopened overnight, and crossings over the Seine, Moselle, and Rhine appeared as if conjured from the debris. This continuity of movement became the backbone of operations such as Patton's dash across France, where entire armored divisions advanced hundreds of miles without logistical collapse. German commanders observed this with growing despair. Reports from the Oberkommando der Wehrmacht described the enemy's inexhaustible ability to restore destroyed communications. Field Marshal Gerd von Rundstedt acknowledged that the speed of Allied reconstruction nullified the strategic value of sabotage. Bridges that German engineers had spent days rigging for demolition were replaced by Bailey bridges within 24 hours. Even the Luftwaffe's attacks on supply routes had diminishing returns, as American road crews simply bypassed craters or laid temporary detours. It was a war of endurance, and endurance was precisely what the American system had perfected. This success did not go unnoticed after the war. Captured German officers, interviewed by Allied intelligence, often cited the U.S. Army's engineering capabilities as a decisive factor in their defeat. In post-war memoirs and technical analyses, many admitted that the Americans had mastered what the Germans had long considered impossible: maintaining full mobility under fire. Their ability to combine industrial methods with tactical flexibility represented a new philosophy of warfare, one that replaced rigidity with responsiveness. The Germans, bound by meticulous planning and centralized command, found themselves outmaneuvered by an army that could improvise and rebuild faster than they could destroy. Beyond the battlefield, the influence of these methods shaped military thinking across the world. The concept of mobile engineering was studied and adopted by other nations, including Britain, France, and later the Soviet Union, which incorporated similar systems of prefabricated bridges and modular road surfaces into their post-war doctrines. The idea that infrastructure could serve as a form of combat readiness became a cornerstone of modern military logistics. From Korea to Vietnam, American forces continued to refine this doctrine, creating a lineage of engineering innovation that traced its roots back to Europe in 1944. The psychological impact of these methods was equally profound. The American Army's relentless ability to move forward demoralized its enemies and inspired its allies. Soldiers learned to trust that no matter how dire the conditions, roads and bridges would reappear, and supplies would continue to flow. This sense of inevitability, that progress could not be stopped, became a weapon in itself. The engineers, working quietly in the background, gave the entire Allied force a reputation for invincibility grounded not in myth but in the mechanical reality of reconstruction. In retrospect, historians have come to see the U.S. Army's engineering achievements as a bridge between the industrial wars of the early 20th century and the technological conflicts that followed. They demonstrated that mobility, infrastructure, and logistics were no longer supporting elements but central pillars of strategy. A tank could not fight without a road, and a plane could not land without a runway. By mastering the art of rebuilding faster than destruction, the American engineers transformed warfare into an exercise in sustained motion, one in which victory belonged not to the side that struck hardest, but to the side that never stopped moving. The legacy of the U.S. Army engineers of World War II extended far beyond the battlefields of Europe. Their wartime experience became a blueprint for how modern societies would think about infrastructure, logistics, and mobility in the decades that followed. The roads and bridges they built under fire were temporary by design, but their underlying philosophy, that the ability to move determined the strength of a nation, endured. It was a lesson that would eventually reshape the landscape of the United States itself. When the war ended in 1945, tens of thousands of engineers returned home carrying the lessons of military construction into civilian life. Many had learned to build with speed, efficiency, and standardization, working in conditions where time meant survival. They brought this mindset into peacetime industries, into highway departments, construction firms, and the emerging field of urban planning. The techniques developed for military convoys and mobile engineering units became the foundation of post-war civil infrastructure. Prefabrication, modular design, and mechanized construction, all concepts born from necessity in Europe and the Pacific, now defined the modern American approach to building. The man who best embodied this transformation was Dwight D. Eisenhower. As Supreme Commander of the Allied forces in Europe, he had witnessed firsthand the crucial role of logistics in victory. He had seen how the Red Ball Express, a massive supply network of trucks running from Normandy to the front, depended entirely on the roads that American engineers had built and maintained at impossible speed. He had also seen the devastation caused when movement was halted, when bridges fell and supply lines faltered. After becoming President of the United States in 1953, Eisenhower sought to apply those wartime lessons to his own country. In 1956, he signed the Federal Aid Highway Act, launching the construction of the Interstate Highway System, the largest public works project in history. Its design was directly inspired by his wartime experience: standardized routes for military logistics, durable surfaces capable of supporting heavy vehicles, and a network that connected every region of the country with precision and redundancy. Eisenhower later wrote that the American highway system owed its existence to the grim realities of war and the determination never to be paralyzed by them again. What began as a military necessity had evolved into a civilian philosophy, that mobility was not merely a convenience, but a form of national security. The influence of wartime engineering extended beyond the United States. In Europe, reconstruction efforts under the Marshall Plan relied heavily on the methods pioneered by American engineers. Across France, Germany, and Italy, roads, bridges, and railways were rebuilt using techniques of prefabrication and standardization that mirrored those employed by the Army Corps during the war. The same Bailey bridges that once carried tanks over rivers were repurposed for civilian crossings. The emphasis on efficiency, durability, and rapid deployment became the cornerstone of post-war European modernization. Even the broader cultural view of infrastructure changed. The war had proven that roads were more than pathways for vehicles; they were lifelines for entire systems. In peace, they became symbols of connection, commerce, and freedom. The image of the soldier engineer, once a figure of wartime necessity, transformed into that of the civil engineer, building the arteries of a modern, interconnected world. The idea that a strong nation must maintain strong roads became a political and philosophical truth shared across continents. By the 1960s, the spirit of the wartime engineers could be seen in every stretch of concrete laid across the American landscape. Highways, overpasses, and tunnels bore the same logic as the temporary roads of Normandy: fast construction, standardized materials, and adaptability to terrain. The legacy of "keep them rolling" lived on, not in convoys of tanks, but in the endless stream of civilian traffic that came to define post-war prosperity. In retrospect, the American combat engineers of World War II had done more than build infrastructure. They had built a worldview. They proved that order could emerge from chaos, that progress could be measured in motion, and that the ability to rebuild was as vital as the ability to fight. Their legacy was written not only in the steel and asphalt of the highways that followed, but in the enduring belief that civilization advances through construction, not destruction, through the unbroken rhythm of roads that never stop leading forward. The story of how American engineers built roads faster than bombs could destroy them was, at its core, a story about the triumph of creation over destruction. In a century defined by industrial warfare and the mechanization of death, these men used the same machinery, bulldozers, cranes, trucks, not to tear the world apart, but to stitch it back together. Their work transformed the meaning of power. It suggested that strength did not lie solely in the ability to conquer, but in the will to rebuild what had been broken. Amid the ruins of Europe, they proved that progress could exist even in the heart of devastation, and that the measure of a civilization was not how much it could destroy, but how quickly it could restore. To the German prisoners who watched this process unfold, it was more than a logistical achievement. It was a moral revelation. They had been raised in a culture that equated greatness with dominance, discipline, and the annihilation of obstacles. Yet in the muddy fields of Normandy and the frozen roads of the Ardennes, they saw another form of greatness, one rooted in endurance, cooperation, and the quiet dignity of work. The enemy they had been taught to despise revealed a kind of strength that no ideology could replicate, the ability to build amid chaos, to bring order where none existed. It was a strength that did not humiliate, but humbled. The engineers' roads became symbols of something larger than the war itself. They represented continuity in a world collapsing under its own violence. Every rebuilt bridge and resurfaced highway carried not only tanks and supplies but also the idea that civilization could persist even when everything around it burned. In that sense, these constructions were monuments, not of victory in battle, but of victory over despair. They embodied the belief that progress was not a gift of peace but a discipline born in adversity. In the philosophical sense, these roads were the arteries of a new world, one that valued movement, connection, and reconstruction over conquest. Where bombs left craters, engineers laid foundations. Where nations once divided themselves by walls and borders, the post-war generations would be linked by networks of highways and trade routes inspired by the same wartime ingenuity. The moral legacy of those roads was that motion itself could be an act of healing, a declaration that civilization would not remain still in ruin. For the Americans, the act of rebuilding was not only a matter of necessity but of identity. It reflected a deep cultural faith in the idea that human effort could overcome entropy. The engineers did not wait for peace to begin rebuilding, they rebuilt peace as they advanced. Their machines moved forward with the same determination as the soldiers they supported, erasing the visible traces of destruction as fast as the war produced them. In doing so, they turned engineering into an ethical act, a defiance of the logic of war that sought to reduce the world to rubble. History would later remember these efforts as technical feats, but their true significance was moral. The Americans demonstrated that a civilization's strength could be measured not by its capacity to wage war, but by its ability to restore life amid war. The roads they built did not merely serve the army, they served the idea of humanity itself, the conviction that movement towards something better was always possible, even in the darkest moments. In the end, the story of the American engineers was not about machines or methods, but about faith in progress, in reconstruction, in the belief that the future could still be built even as the present collapsed. For the prisoners who witnessed it, it was a glimpse of a different kind of victory. For the world that followed, it was a reminder that the greatest weapon of democracy was not destruction, but the will to repair. The roads that once carried convoys to the front would, in time, carry nations toward peace, proving that the legacy of creation endures long after the noise of war fades.